So hello, I'm Chester. I'm a graduate student in the RISE lab. Before we begin this tutorial, I just want to remind you that we have a Slack channel available to you to ask questions during this tutorial. You can ask either in the RISECamp 2019 channel as well as the MC2 channel. So we'll also have TAs walking around during this tutorial to help you out if you have questions or get stuck. Okay, so MC squared stands for multi-party collaboration and co-opetition, and this is actually a series of sub-projects in the lab, all pertaining to this topic. Today we'll be demonstrating Federated XGBoost, which is an extension of the XGBoost framework in the federated setting. And the federated setting allows multiple parties to jointly compute a model over the collective data. And in this case, we will need a centralized aggregator server as well as members of the federation. And in this setting, instead of sending all the data to the aggregator, the parties only need to send summary statistics. And this provides two benefits. One, it conserves bandwidth, and two, it reduces information leakage. So for the purpose of this tutorial, we will be using the Higgs-Boson data set. Higgs-Boson is an elementary particle in physics created by the quantum excitation of the Higgs field. The features in this data set represent the kinematic properties of a signal process measured by experiments run in a particle accelerator. And the labels are whether or not these signal processes are ones in which a Higgs-Boson particle decays into two tau particles. So basically, we'll be using this data set for a binary classification task. So at this point, because we are doing a tutorial on multi-party collaboration, we ask that you please form a federation by getting into groups of 4 physically. And once you've done that, please choose a member of the team to act as the centralized aggregator. So please be social, grab it in teams, and walk around. Okay, it looks like everybody is good now, so we will start. Please begin in the exercise 0 notebook. And for the purpose of the tutorial, we have built a mock public key infrastructure service to simulate the real one that you would use in real life. Our Pgi service is by no means robust, so please do not try to attack it. So yeah, let's begin. First, we would like to have everybody please register into the Pgi service. Enter your username, which will be the email address that you use to log into the rise.camp portal. And it's important that your username is unique, and hopefully your email address will enable you to do this. Okay, once you have done this, please upload your information to the Pgi. And once we've done this, we can verify that the information has indeed been uploaded. Again, if you are having issues, please raise your hand and somebody will come help you. Okay, once you have done this, we are now going to split roles into the aggregator role and the member role. So you should have delegated an aggregator at the beginning of this. So if you are an aggregator, please click the aggregator button in the notebook. And if you are a member, please click the member button. And for this, I will split my screen into the aggregator and the member notebooks. So here for each role, we have listed the corresponding API for that role. We have some stuff for you to do here. So basically what we'll be doing is we will be creating a federation first, and the aggregator will be doing this. Once the aggregator has created the federation, all the federation members will join the federation, and once that is complete, everybody can verify that all members of the federation have joined. So I'll give you a few minutes to do that. Okay, hopefully everybody has not zoomed too far ahead, but I'll be showing what we need to do. So aggregators, we need to include a list of all the members here. And then we will be creating a federation. Just like so. And once that is complete, members can join the federation by inputting the aggregator username. And joining the federation. And once that is complete, we can check that everybody has joined. Has everybody reached this step? Almost? Okay. Which notebook? This one? Okay, so we have one last step until we complete this notebook. After you have verified that everybody has joined the Federation, aggregators, you can now save all the members' public key and IP information by calling this function. And members, you can do the same, save the aggregators' information. And I may have forgotten why we need to do this part. So in our federated learning scenario, we will be requiring communication across parties in order to collaboratively learn. Can we get a TA to the front, please? Okay, have most people finished exercise 0? Okay, it looks like people are still working. Okay, due to time constraints, we'll have to move on. Please ask someone to come over if you are still stuck. So here at the end of exercise 0, we will introduce the following two exercises that we will do. The first exercise is single-party XGBoost on single-party data. So in this exercise, we will be independently training a model. Independently meaning that you, one party, will train on only your party's data. And in the second exercise, we will be performing federated training in the multi-party setting. So let's move on to exercise 1. So for this notebook, the content is the same for all members of the Federation, including the aggregator. So I'll be just showing one notebook. So as I mentioned before, in this setting, each party independently trains their own model on their own data. So here, I'll also give you a few minutes to try to do this yourself before going forward. Okay, I'll now show the answers. So first, let's run this cell to import the necessary libraries. And then we'll be doing some training data pre-processing. Namely, we'll be splitting the training data into features and labels to properly pass into the training function. After that, we'll be doing the same with the test data, and you can examine the data here if you would like. After that, we will be training the actual model. And using the model to predict. So this cell shows you the accuracy and the AUC that your local model got. These accuracy and AUC numbers should differ between parties because each party has different training data, and that's important. So the accuracy that you got should be anywhere between 65 to 75%, around there. Has anybody not yet reached this step? Okay, cool. So now we'll move on to exercise 2. Exercise 2 is the fun part. It's the federated training of XGBoost. Okay, so in exercise 2, again, it's the federated training exercise. So just to reiterate what has been previously said, in federated training, there are a couple main steps. The first step is that the aggregator will send a model to all the parties. The parties will train the model locally on their own training data. After that, the members of the federation send updates that they made to their model back to the aggregator. The aggregator will finally aggregate all of the updates and then apply that aggregated update to the final model, or not the final model, but to the model, and then the model gets broadcast back to all parties, and then this process iterates. Okay, so in this notebook, the content significantly differs between the aggregator and the members. The aggregator, because he is the so-called leader of the team, will perform all the actual training, and during this time, members can either look at the aggregator screen to see what he or she is doing, or they can take a break. After that, everybody in the federation will perform model evaluation. So let's get started. So the aggregators, which is my notebook on the left, please import your helper functions and enter your username. And after that, we can configure all the communication by getting the IPs of all members in the federation. And then this right here is an example of a training script that we wrote for you. This contains example usage of our API that we found, that you can find listed in our repo. Using this training script, we can perform federated training. So you can start the training job like so, and of course, because again, there is different content in the aggregator and member notebook, only the aggregators need to run this. You should be receiving some output similar to this aggregators. And this process should take less than a minute for training. Okay, so once the federated training has finished, the model that has been trained will be broadcast back to all parties. And because of this, all parties will be able to evaluate the model. So I'm going to go into the member notebook and evaluate the model that we jointly trained. So you can just run all these cells. Basically, they do the same as in exercise 1. They do some test data preprocessing and evaluation. So hopefully, if you are in larger groups than I am, and I'm in a group of 2, you should have seen, you should see higher accuracy and higher AUC. And this is because in the federated setting, we are computing our model on more data. Ideally, if you are in a group of 4, you should see an accuracy of about 90%. So this just comes to show the benefits of using federated training and federated learning as compared to computing a model independently. And since it looks like we have more time, you can go back to the beginning of the tutorial and change roles if one of you is yearning to be the aggregator. But for now, this concludes our tutorial. So please let us know how we can help you about your use cases. And yeah, thank you.